now I'm recording. Yeah, so we have 8x minus 2 is equal to negative 9 plus 7x. We've got a variable on each side. We don't want that. We want to make sure that all the variables are on the same side. And personally, I like to get them all on the left-hand side. So what we want to do is 8x minus 2. And we want to subtract 7x from both sides to get rid of it on the right-hand side. We can't have it on both sides. So minus 7x. And that's going to be equal to negative 9 plus 7x minus 7x, which, of course, is just going to be negative 9. Over on the left-hand side, we have 8x and negative 7x. Those are like terms, so we can combine them into just x. So we have x minus 2 is equal to negative 9. And then follow our usual strategy. We just have this one step here to take care of. So we want to add 2 to both sides. And then x is equal to negative 7. Any questions about that one? Does everyone understand the strategy we used? Awesome. Okay, and then for number 4, we have a plus 5 is equal to negative 5a plus 5. So once again, we're going to want to get all of the a terms onto one side. So we've got a plus 5, and we want to add 5a to both sides to get rid of the 5a on the right. Plus 5a. This is essentially we're subtracting minus 5a. You can think of it like that. But I like to think of it as just adding 5a. So that'll obviously cancel out on the right-hand side, which means that, sorry, that should be like that, which means that we have a plus 5a is 6a. 6a plus 5 is equal to 5. If we subtract the 5 now from the left-hand side, we've got 6a is equal to 0. Subtract 5 from both sides, I should say. And that again means that a is equal to 0. For whatever reason, this sheet has a lot of variables equaling to 0. Yep.
On a test, would you like us to do explain why 6a is equal to 0, like do 6 times a divided by 6?
No, I mean, if you just jump like that, we know what you're talking about. Yeah, that's fine. It's fine if you want to. If you want to do 6a divided by 6 is equal to 0 over 6, go for it. But like we said, we just want to see the key steps in between. That's what we really want to see. Okay, for number 5, it's a bit of an interesting one where we've got 4m minus 4 equals 4m. So that should set off some alarm bells in your head in the terms of that doesn't sound right. Is there a number where 4 times the number minus 4 gets you that same number? Well, we'll see. So we want to, again, bring everything onto the same side in terms of our variables. So we'll want to subtract 4m from both sides to get it onto the left. So 4m minus 4m gets you 4m minus 4m. So on the right-hand side, we've got 0. And on the left-hand side, if we combine our terms 4m and minus 4m, we get 0m minus 4 equals 0. So that's interesting. 0 times a variable term. If we add 4 to both sides, we then have 0 times m is equal to 4. So 0 times some number equals 4. That's weird, okay? And if we wanted to actually divide out the 0, we'd have 0m over 0 is equal to 4 divided by 0. So for so many reasons, this doesn't work. If you ever get a situation where you have 0 times a number is equal to anything other than 0, there's no solution. So this is an interesting case. Not every equation has a solution. As much as we like to convince you that's true, not everything can be solved. And that's okay, you know? Just the way it's set up, there's no solution to this. You need to know that. You need to be able to tell me there's no solution. Any questions about that? Great. So we can do maybe 2 more, and then I'll turn it over to you. So on here, we've got p minus 1 is equal to 5p plus 3p minus 8. So we've got lots of terms with p in them. I'm going to bring them all onto the left-hand side. So we've got p minus 1 minus 5p minus 3p. And that's going to be equal to 5p plus 3p minus 8 minus 5p minus 3p. I don't want to write all of that, so I'm just going to simplify it to minus 8. But just know we've taken from the right-hand side, we've subtracted off 5p minus 3p. And that's just left us with negative 8. Okay, now on our left-hand side, we've got a whole bunch of like terms to combine. We've got p, negative 5p, and negative 3p. So 1 minus 5 minus 3 is negative 7. So we've got negative 7p minus 1 equals negative 8. Add 1 to both sides. Negative 7p equals negative 7. And of course, if we divide both sides by negative 7, you'll get p equals 1. Okay. For the last one, I want to take up with you together. It's going to be number 14, actually. Because remember, I said expand any brackets with variables in them. And to this point, it's not really clear why I said that. But let's take a look at number 14. We've got 5n plus 34 is equal to negative 2 times, in brackets, 1 minus 7n. So right away, we can't collect and combine the variable terms until we've distributed the negative 2 into these brackets. Because we can't just add negative 7n to both sides here. That won't take it away, because we don't just have negative 7n. We've got negative 2 times 7n, times negative 7n. So we actually need to expand the brackets first before we collect and combine those variable terms. And this is true anytime you've got some variable that is in the bracket and some variable that isn't in the bracket. So not in bracket. In bracket. So anytime we have that, we need to expand the brackets so that we can combine the like terms. So that means we've got 5n plus 34 is equal to, and if we expand, negative 2 times 1 is negative 2. Negative 2 times negative 7n is going to be 14n. So we've got 5n plus 34 is equal to negative 2 plus 14n. And now we can combine these like terms. So we can bring the 14n over to the left-hand side. We can say 5n minus 14n plus 34 is equal to negative 2. 5n minus 14n, that's going to be negative 9n. So negative 9n plus 34 equals negative 2. And then we can bring that negative 34 over there, because now this is just a two-step equation. So deal with our subtraction first, or our addition in this case. Negative 9n is equal to negative 36. We've subtracted 34 from both sides here. And then negative 9n is equal to negative 36. We need to divide by negative 9 to get rid of the multiplication here. So that means that n is equal to 4. Negative 36 divided by negative 9. Two negatives makes it positive. 36 divided by 9 is 4. So yeah, that's why we have to expand the brackets if we have some variables that are in brackets and some that aren't. Any questions about any of that? Okay, well, it looks like you've got about 10 minutes before the break, so I'd encourage you to, if you haven't already, finish up the two-step equations and work on the rest of the multi-step equations. And I'll put the solutions for the multi-steps up on the board, and I'll come around and help you out if you have any questions at all.